Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. So, I'm Jeetendra Dixit. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. So first, let me check my sound, then we will continue this session. All right, so, Okay, so before starting, let me tell you about the Unacademy subscription. As you know, Unacademy is India's largest online learning platform, and once you get the subscription for IIT-JEE, then you get daily access. You get access to daily live classes of all the JEE educators who are teaching on Plus. All right, you can follow their courses. It's very systematic. Everything is pre-planned. You get to know the schedule in well advance. You can see the course planning. All right. Apart from that, you can attend. You can watch their offline sessions also, recorded sessions. You can watch. You can download the sessions and watch them offline. All right. You can clear your doubts during the live session already. Doubts clearing sessions are also there. You can attend those sessions as well. If you are not taking Plus subscription, then you can attend special classes. So every day special classes are going on the platform. You can attend those special classes for free, okay, without taking the subscription. This Plus subscription charge is 56,000 for 1 year, and after 10% discount, it is 50,400. And for 2 years, it is 86,000. And I'm sorry, this is not this. This is the Plus subscription that was for Iconic. I'll tell you that later. So Plus subscription for 12 months is 38,500, and for 2 years it is 56,000. If you use this code JEET1, use my code, so you'll get 10% discount. You'll have to pay this much. All right. This is Iconic subscription, which is new. So in Iconic subscription, you get everything with all the benefits we are getting in Plus. All right. So all those benefits. Apart from that, you'll get personal coach who will guide you throughout. So an expert who will guide you throughout all the competitive exams you are writing, you're about to write, and your test preparation, test analysis will be in a personalized manner. Personalized feedback will be given to improve your time management and exam approach. And study planner will also be customized. All right. So weekly reviews and all these things will be. So basically, that all the personal attention by an expert, advices, suggestions, everything in your preparation to enhance your performance. So this is Iconic subscription, and charges of Iconic are this: 56,000 for 1 year and 86,000 for 2 years. And after 10% discount, this much you'll have to give. So use JEET1 to get the discount. All right. You can download this Unacademy's learning app from Play Store, and after downloading, you can subscribe for Plus or Iconic. Now let's begin the session. So we were doing range, and we'll continue that. So today I'll tell you some more important points about the range. Say this expression y is equal to x plus 1 upon x. So this is a very important expression, and sometimes we ask questions based on this also. All right. So I'll tell you how to use it. How to use this. Suppose first let's plot the graph of this function. So graph of this x plus 1 upon x is like this. Like this. All right. Like this. This is the graph of x plus 1 upon x. And this is a very, very important expression. So many questions based on this graph, based on graph of this function. you will see in competitive exams. Okay, so I'll tell you everything about this function. 1 minute, bache. Okay, so see how to do it. The range of this graph is range of this function y is equal to x plus 1 upon x is this point is 2, which is minimum value, minimum positive value, we can say. It occurs at x is equal to 1, and maximum negative value is minus 2. This is maximum negative value, which is minus 2, and it occurs when x is equal to minus 1. All right, so range of this function is minus infinity to minus 2 union 2 to infinity. All right, and how do we find the range? If x is positive, we can apply AMGM, and you can say it is always more than or equal to 2, right? And domain is x belongs to all real numbers except 0. All right, this is domain. Now let's do some changes and see how to use it. Now see, if your function is y is equal to sine x plus cosec x, all right, cosec x, and you want to find the range of this function, sine x plus cosec x, find the range of this. So we can use this function, the function which we have just studied. How to use it? I'll take sine x is equal to t. All right, now I know that t belongs to minus 1 to 1, minus 1 to 1. Obviously, you have to remove 0 because sin x cannot be 0 in this expression. So y is equal to, it is going to be t plus 1 upon t. All right, now this is your question, and t belongs to minus 1 to 1. And yes, of course, you'll remove 0, right? T cannot be 0 now because t is in the denominator. All right, so we need to find the range of this function t plus 1 upon t. And obviously, we can take the help of this graph which we have just plotted. Now suppose your x belongs to only in this range, minus 1 to 1. Then what will be the range? You'll see range will remain same because this will be the graph of t plus 1 upon t. It will come up to 2, from plus infinity to 2, and minus infinity to minus 2. All right, so it will cover the complete range. It will cover the complete range. So range is going to be y belongs to minus infinity to minus 2 union 2 to infinity. There's no difference. All right, no difference. But I'll tell you more examples based on this graph. All right, and we'll see what will be the change if we change the range of inputs. Okay, so in place of x, you can take you can put many functions, and by putting those functions, you'll get very good expressions whose range you can find using this graph. All right, so I'll tell you. First, we'll plot the graph of this function. So graph of this is, again, I'm making like this, and all right, like this. So this is 2 and this is minus 2. All right, I can see. So fx is equal to, now let's change the previous function. So I am giving you another function. Say it is cos square x plus sec square x. All right, and you can add some constant also, so that we will do later. We need to find the range of this function, cos square plus sec square. Yes, of course, you can apply AMGM and you can find the range easily because these are positive expressions. But let's do it using graph because graph will be more generalized than AMGM. Okay, I'll tell you how. So here you can apply AMGM and you can find the range easily. I'm taking cos square x is equal to t. All right, and by taking cos square is equal to t, I can immediately write t belongs to 0 to 1. All right, t belongs to 0 to 1. But 0 is going to be excluded for this function. So if I write this function again as a function of t, then it is going to be t plus 1 upon t, where your t belongs to, now you need to leave 0 to 1. Okay, 0 to 1 because t is in denominator. So now this is your question. Okay, you need to find the range of this. So see how to find the range. So now your t belongs to this interval, only this much, all right, up to here. So your range is going to be this, only this will be the graph, right? So if you map this graph on y-axis, it is going to give you all these values 2 to infinity. That's it, that's it, that's it. So that is going to be the range, okay? So f of t is going to be 2. 2 will occur because x for t is equal to 1, you'll get f of t is equal to 2. So 2 to infinity, okay? So 2 to infinity is the answer. So now you can see the range is half because t was only taking positive values. All right. Now let me give you one more example. Now suppose you need to find the range of x square plus 1 upon x square plus 2. That is your question, okay? You think about it for a minute, then I'll tell you how to find the range. Try this sum. Try it for a minute, then I'll tell you how to do it. All right, so let's do it. I hope you have completed it. So I'll tell you the solution. It's very interesting. All right, so let's do it. First of all, I'll take x squared plus 2 as equal to t, x squared plus 2. So to make x squared plus 2 plus add plus 2 and subtract plus 2. So now you can see this expression is of t plus 1 upon t type minus 2. That's okay if you have minus 2, because that you can subtract later in the range of x square plus 2 plus 1 upon x square plus 2. So now you can take x square plus 2 is equal to t, and your t belongs to 2 to infinity. All right, t belongs to 2 to infinity. So now this y is going to be t plus 1 upon t minus 2. Okay, so that is going to be your function. Now you first find the range of this. Range of t plus 1 upon t. I'm sorry. First, let's find the range of t plus 1 upon t. T plus 1 upon t, where t belongs to 2 to infinity. Okay. So now see, your 2 is here, 2 to infinity. So that is your domain now. So what is going to be the range? Now, this range is not going to be 2 to infinity, right? It will be different now in this case. So this is the graph. This will be the f of t. These are the values of t plus 1 upon t, which actually will start, if you put 2, then it is going to be 2 plus 1 upon 2. This point is going to be 2 plus 1 upon 2, which is the minimum value, right? And then you'll get all these values. If you map this graph on y-axis, this part on y-axis, it will give you, so t plus 1 upon t will belong to 5 by 2 to infinity. I hope you're getting it, all right? So we have got this, t plus 1 upon t is greater than or equal to 5 by 2, and of course less than infinity. Now you can subtract minus 2 to find the range of f of t or y, t plus 1 upon t minus 2. So constant you can subtract later. By doing that, this you'll get 1 by 2, and infinity minus 2 is nothing but infinity. So range of this y belongs to is 1 by 2 to infinity, and this minimum value will occur when t is equal to 2. All right, you can put t is equal to 2 in this, and you can check it is going to be 1 by 2, the least value. So least value. So I hope you learned this method. This is very, very interesting function. All right, I'll give you one more example. Now suppose you have this function x square minus x plus 1 upon x square minus x plus 1. Okay, find the range of this. Find the range of this. So you try this. I'm just making the graph so that I can explain it easily to you later. So keep trying. Try to find the range of this. So this is the graph of y is equal to t plus 1 upon t. All right, this is the graph. So try this one. We'll use this graph to find the range. Okay, we'll use this graph. All right, so let's do it then. I'll explain how to do it. So like in the previous questions, we'll again uh, we'll express this expression as t plus 1 upon t. So what should be your t? Obviously it should be x square minus x plus 1, because you can add and subtract plus 1 to this expression, right? But you can't subtract 1 from this denominator. So that means you write x square minus x plus 1 plus 1 upon x square minus x plus 1, all right, and minus 1, because you have added plus 1, so you need to subtract plus 1. Okay, so we have written like this. 1 minute. Then I'll take x square minus x plus 1 is equal to t. And what is the range of this x square minus x plus 1? Minus d by 4a to infinity, and d of this function is minus 3 by 4. So range of this function is plus 3 by 4 to infinity. Okay, vertex of this is 1 by 2, is vertex of this parabola, this quadratic, is 1 by 2 comma 3 by 4. So minimum value of this quadratic is 3 by 4, and maximum, you know, to infinity. Not maximum, it will go up to infinity. So we have got the range of t as well, right? So this is t. T is equal to this is equal to this. So we have got the range of t. Now our question is this. We need to find the range of t plus 1 upon t minus 1. And now we know what is our t, all right? So first we'll find the range of t plus 1 upon t when t belongs to 3 by 4 to infinity. Okay, let's plot it. So 3 by 4, this point we know, this point is 1. This vertex, lowest point, lower, we call it local minima also. 3 by 4 will be somewhere here before 1. So this is your t. If I map it on y-axis through this graph, then this will be these are the outputs when t belongs to 3 by 4, all right, to infinity, this interval. Then your fx belongs to this, right? You can see. So where is your minimum value? Minimum value will be same as which was earlier, that is plus 2, minimum positive. That will be plus 2 because this graph is starting from here. This value will be 3 by 4 plus 4 by 3, and then it will go down, and minimum will come out to be 2, and then it again will go to infinity, right? So minimum of this is going to be, so this t plus 1 upon t is going to be, you put 3 by 4, so it is going to be 3 by 4 plus 4 by 3 to infinity, all right? This is the minimum. Oh, I'm sorry, not this one. I just did this opposite. Okay, so minimum is not at 3 by 4, minimum will be at 1 only, and that is 2. So 2 to infinity. Okay, so t plus 1 by 2 is 2 to infinity. That 4 by 3 plus 3 by 4 is actually more than 2. Okay, so this is the range. So we have got the range of t plus 1 upon t. T plus 1 upon t is giving you the range 2 to infinity. Then you just need to subtract 1. So it is going to be t plus 1 upon t minus 1. It will be infinity only, and this will become 1. So range of this function is 1 to infinity. And 1, you can see, will occur when t is equal to 1. When t is equal to 1, if you put in this, you'll get 1. And what should be the value of x? For that, you need to solve x square minus x plus 1 is equal to 1. That means 0 or 1. Okay. So when you put x is equal to 0 or x is equal to 1 in this expression, you will get 1 minimum value. Okay. So this is the range. I hope you have got it. Okay. This was a very beautiful concept. You can apply it using this graph. Now, let me tell you range of some expression which is addition of two expressions. Let's say it is sine inverse of, say, x square minus 1, x square minus 1 by 2, all right, and plus tan inverse of x square plus 1. Say this. Now this is your expression which is summation of two functions. Hello, Lalit Kumar. Okay, it's a summation of two functions. We need to find the range of this. So how to do it? How would you start? See, when you add two functions or subtract two functions, first of all, we change. In this case, you can see this x square. X square is same in both the functions. Sine inverse is an increasing function, and tan inverse is an increasing function, right? So if inputs of both the functions are same, then obviously you can say sine inverse and tan inverse will be increasing functions. So if you take x square is equal to t, all right? So obviously t will be from 0 to infinity. You can rewrite this expression as sine inverse of t minus 1 by 2, okay? So t minus 1 by 2 is an increasing function whenever t is an increasing function, plus tan inverse of t plus 1, all right? See, in this case, in case of sine inverse, what is the minimum value of t? See, t is more than or equal to 0, right? More than or equal to 0. Okay? More than or equal to 0. So t minus 1 by 2, t minus 1 by 2 will start from minus 1 by 2. I hope you're understanding this, right? So if you start from 0, then this t minus 1 by 2 is an increasing function, and t plus 1 is also an increasing function. But I want to add one point here. Tan inverse is always defined, but sine inverse is not always defined. This t minus 1 by 2, which is the input of sine inverse, that should be between minus 1 and 1. So that means t should be between minus 2 to plus 2, and just add plus 1 and plus 1. That means t should be between minus 1 to 3. So that is the domain of this function. And domain of this tan inverse is all real numbers, so there's no difference. So that means intersection of domain of both. So finally we have got minus 1 to 3, but t is starting from 0, we already know. So finally we have got the domain. T belongs to 0 to 3, okay? Because we can't take t negative. T is starting from 0. So for 0 to 3, this function will be defined, and this is always defined, but we need to define both. So it should be 0 to 3. Okay. Now we have got this t 0 to 3. So for t 0 to 3, t minus 1 by 2 is increasing and t plus 1 is increasing. All right. Let's discuss about these function. This function is increasing and this function t plus 1. It's a linear function. So they are increasing function because their coefficient of t is positive. Then sine inverse of this function is also increasing, and tan inverse of this, because tan inverse of increasing is increasing, right? Will be increasing. So increasing plus is increasing function is increasing. So overall, this function is an increasing function for t belongs to 0 to 3. All right. So this is what we have got. You need to check whether both the functions in the given interval are increasing or decreasing. All right. If they both are increasing for the domain of that function, then their sum addition will be increasing. All right. So we have got that fx is increasing. So minimum of fx minimum will occur when t is equal to, basically now it's function of t. So when t is equal to 0, and that is going to be sine inverse of minus of plus tan inverse of 1. All right. And f of maximum, f maximum is equal to when t is equal to 3. Okay. So if you put t is equal to 3 in this, then it is going to be sine inverse of 1 but tan inverse of 4. All right. So this minimum value of fx is 1 pi minus pi by, so this is minus pi by 6 plus pi by 4. Okay. If you take LCM, this is going to be pi by 12, pi by 20, 12, I think. Yeah, pi by 12. Yeah. This is pi by 12, and this value is going to be pi by 2 plus tan inverse 4 is not a standard angle, so you need to write tan inverse 4 only. All right. This. So finally we have got the range f belongs to, this range is pi by 12 to pi by 2 to pi by 2 plus tan inverse of 4. All right. That is the range. So I hope you understood this type of problem. I'll give you easy problem to solve. Okay. You need to find the range. Find the range of sine inverse of x plus tan inverse of x plus cot inverse of 1 minus x. All right, let's see if you can do it. Apply the concept which I just told you. All right, so let's start it. I'll solve this problem. Are you guys getting? Okay. No, see, first of all, sine inverse is increasing function, increasing, but x belongs to -1 to 1, right? So sine inverse of x is increasing. Tan inverse is increasing function. Tan inverse of x is also increasing, right? And x belongs to all real numbers. See, cot inverse of x is decreasing, right? But cot inverse of 1 minus x, that means decreasing of decreasing function, that will become increasing. If you put decreasing function inside a decreasing function, that becomes increasing, because 1 minus x is a decreasing function and cot inverse of x is also decreasing function. So cot inverse of 1 minus x will be increasing function. So if input of a decreasing function decreases, then that overall composite function will increase. All right. So this is not cot inverse x. This is cot inverse of minus x. All right. 1 minus x. So cot inverse of 1 minus x is also increasing. All right. Also increasing. And this x belongs to all real numbers. Okay. So first of all, domain, if you write the domain, so domain will be intersection of these three, this, and this. So that is nothing but -1 to 1. Now all three functions are increasing function. So fx is an increasing function for x belongs to -1 to 1. I hope you have got it. So now f minimum is going to be for x is equal to -1, and that is sine inverse of -1 plus tan inverse of -1. And if you put -1 in this, it will be cot inverse of 2, right? So now you can write the answer. There's pi by 2, minus pi by 2, minus pi by 4. So it will be minus 3 pi by 4 plus cot inverse of 2. And f maximum when x is equal to 1. So that is going to be sine inverse of 1 plus tan inverse of 1 plus cot inverse of 0. So cot inverse of 0, what is the value of cot inverse of 0? Cot inverse 0 is pi by 2, all right? So this is pi by 2, this is pi by 4, this is pi by 2 again. So it is going to be pi plus pi by 4, so pi plus pi by 4 is 5 pi by 4. So range of f belongs to -3 pi by 4 plus cot inverse of 2 from this point to 5 pi by 4. So I hope you have got it. Okay. So for 1 we are getting the maximum value, for -1 we are getting the minimum value. All right, this is the range. Now I'll give you some examples to solve. This is one example. You practice it, you solve it, and then I'll discuss you. Okay, so now I'll have some practice questions to find the range. All right, so let's discuss it. We need to find, this is a simple question. So we need to find the range of y, okay? So fractional part of x, is always between 0 and 1. Because you need to take log of this, so fractional, so you need to leave 0. So fractional part of x will be between 0 and 1. Why? Because you can't take log of 0. So leave 0. Then you are taking the leave, you take fractional part of x is equal to t, all right? So this means t belongs to 0 to 1. Fractional part of x is equal to t. T 0 to 1. And you need to find the range of log of t, basic. So it's very simple to map. Either you take the log here, log 0 is log 0 plus means minus infinity, or you just take the graph, take the log, map the graph. So this is the graph, all right? You can see when your t belongs to 0, this is 0 and this is 1. So when t belongs to in this interval, all right, what will be your log of t? Log of t will be this. These are the values of log of t. And you can see this covers all the negative interval, right? Minus infinity to 0. And because t is, okay, so that will be your log of t, which will belongs to minus infinity to 0, and 0 actually will not be included. So he's saying which of the following are correct, all right? So now options you need to read carefully. He's saying that y belongs to minus infinity to plus infinity. Yes, y belongs to actually, because y belongs to minus infinity to 0, so it will surely belong to minus infinity to plus infinity. So that is always true, right? This is always true. It's a multiple correct type of. He's saying y is greater than 0 for x x belonging to 1 to infinity, that is wrong. Okay, y cannot be more than 0. If you say that y belongs to minus infinity to plus infinity, that is right. Okay, but that is not the range. That is not the range. You are saying that y, this function log of fractional part, belongs to this interval. That means it's a real. Okay, so that is real. That is all right. But B option is wrong because y cannot be more than 0 for all real y. Okay, now read this option carefully. Option C says for all real y, when y is real, then x belongs to real numbers minus integers. Of course, correct, because x cannot be integers. If x is integer, then fractional part of x will become 0, and log of 0 is not defined. That's why we have removed 0 from the range of fractional part. All right, so yes, this is perfect. C option is also correct. Now the last one says that when r belongs to, then y is less than or equal to 0. Perfect. Y is actually less than 0, but even if you write y is less than or equal to 0, that is okay, because it's not less than, it's not y is equal to 0 only, it is less than or equal to. So when you say or, then okay, even if one of these statement is correct, like you're saying that a is either less than 1 or less than 0. Okay, and in actual sense, if your x is less than, the statement is correct. All right, because it is less than 0. So even if you add or it is less than 1, then that is fine. So this D option is all right. D option is also correct. So this was the question. I hope you understood. Now this second question, this one is a very simple question. We were doing such questions yesterday also, so you do it today. So practice question. Function is sine inverse of, so I've told you the concept in yesterday's session, how to find the range of composite functions. We start the question from the innermost function. All right, so you should start this question by finding the range of x square plus x plus 1. So I hope you would be getting that. Sorry. All right. Okay, so let's do it. This is very easy problem. So let's start with this function x square plus x plus 1. And if you know this parabola, then its minimum value occurs when x is equal to minus 1 by 2. So its vertex is minus 1 by 2, comma, minimum value is 3 by 4. So if you put minus 1 by 2, you'll get 3 by 4. So this is always greater than or equal to 3 by 4 to infinity. And how to find the range? This formula is minus b by 2a to find the vertex, comma minus d by 4a. So in this way you can write the range minus d by 4a to infinity. Now you take under root, you can take under root. Under root is an increasing function, you can put under root function, but the only problem is that you should have a positive interval. So yes, you have positive interval, the entire interval is positive, so you can take under root of all the numbers. It will be, minimum will be under root of 3 by 4, minimum of under root of x square plus x plus 1, and maximum will be under root of infinity. All right, that is fine. Now you need to take the sine inverse, but sine inverse you can take only of the values which lies in the interval minus 1 to 1. So these values are actually going beyond 1, so you need to leave all those values of x square plus x plus 1 under root which are more than 1. So we'll leave those values. Those values are of no use for sine inverse. So after leaving those values, we will only write the values which lie in the interval minus 1 to 1. So these are the only values of under root of x square plus x plus 1 which lie in minus 1 to 1. So now we can put sine inverse on these values. We can take sine inverse of these values. So sine inverse of root 3 by 2, that will be the least value. Sine inverse of under root of x square plus x plus 1, all right, and less than or equal to sine, I'll write it here, less than or equal to sine inverse of 1. Okay, so I'll write it here. So sine inverse, that means fx is less than or equal to sine inverse 1 is pi by 2, and sine inverse of root 3 by 2 is nothing but pi by 3. So range is pi by 3 to pi by 2. C option. Now we will do this question. This is a very good question. Oh, hi Vamsi. Oh, no problem. You can watch it later. So actually, I discussed a very good concept today in the beginning of finding the range of some special functions. So you can using graphs. So yes, you can watch it later. The first 30 minutes I have discussed that particular expression x plus 1 upon x and finding the range of all such expressions which are of type x plus 1 upon x using graphs. All right. So you can watch it later, no problem. Now we are doing some practice questions in the end, and I'm about to finish now. So I've taught the concepts in the beginning today, so you can watch this video later. All right. Try this particular sum. This is a very, very good question. Very conceptual one. The range of fx is proper subset of set of real values than the most exhaustive set in which alpha lies. The problem is, if you want to understand this question, the question says that the range of fx is a proper subset of set of real numbers. So range of this function is a real number. Okay, what is the problem? The domain of this function is x all real numbers minus alpha. Okay, alpha is not in the domain. If alpha is not in the domain, you can cancel it. But when you plot the graph of this function, then the value which will occur at alpha will be removed. See, if I explain it like this, say alpha is here, okay, and this point now will be excluded. So you can see, suppose this is y-axis, then this value will be excluded now. This value will be excluded in the range, which is corresponding to alpha, So f of alpha will not be there because it is occurring only once. For alpha only, you are getting f of alpha. For no other, you can see on the graph, for no other x, you are getting the same value, f of alpha. But if your alpha would have been here, suppose alpha is here, then there's no problem. Why there's no problem? Because you can see if you draw a horizontal line, then you can see this particular f of alpha will occur thrice. It will occur here also. This is some other point, and this is some other point. So even if you remove alpha, then range won't be affected, because f of alpha which you are removing for alpha, that will occur, appear again for some other x. There are two more x. So see, what should be your answer? If I draw, where should your alpha lie? So that range will remain R. So if I draw this line, see this line, okay, as well as this line, okay, as well as this line. So you can see this is the leftmost point and this is the rightmost point. So in this portion, you can see the graph of fx is many one between this. This is say point x1 and this is point x2. So between these 2 points, this graph is many one, completely many one. That means every f of x you are getting at least twice or thrice actually. Okay, so at least twice or thrice. If you pick this, if you take your alpha here, you will get f of alpha, which will be for this point as well, which will be for this point as well, right? 3 points. But if you take outside, if you take x1, if you take your alpha outside x1 and x2, okay, then your f of alpha will be unique. That will not occur. So your alpha should be in this range, okay? So how to find this x1 and x2? Okay, I'll tell you how to find. First of all, you need to find out these points. These points, okay? These points say A and B. A and B are the roots of A and B are the roots of f dash x, right? So first we'll do f dash x, we'll find the roots. Then we will find these values, which are the extreme values, the horizontal blue lines, which I have plotted, okay? And then we will solve these blue lines. Say this point is this point is actually f of A, and this point is f of B. Then we will solve fx is equal to f of A, and we'll get 2 values, right? You can see you'll get 2 values. One value will be 3 values actually. 2 values will be A only. You can see your blue line, when you solve this blue line and this red curve, right? This red curve, then they will intersect thrice, and this A will be the repeated root because this blue line is touching the cubic function, right? So let me solve it, then I'll keep explaining it, because explaining it in once, in a stretch, might be confusing. So first of all, I'll write this: fx is equal to 2x cube minus 9x square plus 12x plus 3, okay? I'll find f dash x, which is actually 6x square minus 18x plus 12. We'll put this is equal to 0. So this is going to be x square minus 3x plus 2 is equal to 0. So it's very simple. X is equal to 1 or 2. I've got these values. These are the roots. So A is equal to 1 and B is equal to 2. All right. I'll plot this graph again so you can take the reference. All right. So this is your x-axis. Doesn't matter where is your x-axis. We just plot a horizontal line. So I'll plot those blue lines again with some other color, say yellow. So this is your y-axis. Okay, so this we need to solve, and we need to solve. First we need to find these yellow lines. Okay, how would you find these yellow lines? I'll tell you. This point you have got, this is a is equal to 1. This point also you have got, this is b is equal to 2. So this yellow line is nothing but y is equal to f of b, and this yellow line is y is equal to f of a. Okay, so put in this. So this y is equal to, first line is y is equal to f of b. B means you need to put y is equal to 2. Okay, so put in this. So it will be 2 into 2 into 2, 8 into 16. This is f of 2 I'll write. So this is 16 minus, as 9 into 4, 36, then 24 plus 3. So it is going to be 24 plus this 40 minus 7. Okay, this is going to be 7. Okay, so this is 7. This is 7, and let me create some space here. So I'll tell you what is this x1. What was required? Let me create some space and I'll continue. Okay. So what is required actually is this. You need this point. This is your x1, and you need this point. This is your x2. Okay. So x1, what is x1 basically? x1 is a root of fx is equal to f of b, right? You can see this yellow line will meet this white curve, this yellow line, this red line. Okay, let me make it red. Will meet this fx at 3 points, 1 here and 2 here. So 2 roots are b, 2 roots are 2, right? So if I write this cubic, this is basically 2x cube minus 9x square plus 12x plus 3 is equal to 7. So if you bring this 7 to left hand side, it is going to be minus 4 is equal to 0. Now its roots are 2 comma 2 comma x1. Okay, why I am writing 2 times? Because you can see this red line is touching this white curve cubic. So when a line touches a curve, that gives you a repeated root. Okay, so 2 roots will be 2 and 1 root will be x1. So easily now you can find applying product of the roots. So product of the roots is 2 into 2 into x1 is equal to minus of minus 4 divided by 2. Okay, so you'll get x1 is equal to 1 by 2. So you've got x1 is equal to 1 by 2 easily. This point is 1 by 2. All right. Now you need to find x2 also. To find x2, first of all you need this yellow line. This is y is equal to f of a. Y is equal to f of a, and f of a is basically put a is equal to 1. So if you put 1 in this, it is 2 minus 9 plus 12. That is 5 plus 3. 5 plus 3 is 8. So this is y is equal to 8 line. Okay, y is equal to 8 line. So now you need to solve again the same process. You need to solve fx is equal to f of a to get this x1. Okay, and sorry, x2. This is x2. So its roots are what? Its roots are 1 comma x1 x2, sorry. Okay, 2 roots will be 1 by the same logic which I have applied earlier. So let's write this cubic. 2x cube minus 9x square plus 12x plus 3 is equal to 8. So if you bring 8 to left hand side, it is going to be minus 5 is equal to 0. So if you apply the product of the roots, the 1 into x1 is equal to 5 by 2. Okay, so x1 is 5 by 2. So you have got x2, sorry, x2. Wow, why am I writing x1 again and again? So this x2 is basically, this x2 is your 5 by 2. So now you have got the answer. If your alpha lies in this interval, okay, okay, in this interval, then range of fx will remain R, even by removing alpha from the domain, even by removing alpha from the domain. So that is the main conclusion. If alpha lies in this interval, say this, you have this point you have removed, so that won't affect the range. But if alpha is outside this interval, say here, and you are removing this point, then this point from the range will be removed, and this point is unique point, okay, in the range. It occurs only for one x, that is alpha. So range will not be exhaustive set. Exhaustive set means it should be all real numbers. So I hope you have got the point. So what is your answer? Alpha belongs to 1 by 2 to 5 by 2. 1 by 2 is included and 5 by 2 is also included. So the question says the most exhaustive real numbers. Oh, okay. So question says the reverse of this, what I was explaining. Question is saying that range should be proper set, proper subset. Proper subset means it should not be equal to R. Range should not be range should be a proper subset of R. Proper subset means at least one element should be less. Okay, so all right. So we have solved the same question. Just we need to take alpha in this interval. Okay, he's saying range should not be R. Okay, so okay, the remaining interval will be our answer. So alpha belongs to, for this question, is minus infinity to 1 by 2, all right, union, and 5 by 2 to infinity. But this 1 by 2 and 5 by 2 will not be included, because if you take 1 by 2 and 5 by 2, then range will become R. So you need to take your alpha here and here. So if you take alpha in these two intervals, then one of the point will be removed from the range, all right? And if one of the point is removed, then it will become a proper subset of R. Proper subset means it should not be equal to the subset. It can be less than, all right? So that is the answer. I hope you've got it. So this was today's session. I'll end it here. We'll continue tomorrow with another part of functions, all right? So thank you guys. I'll try to bring some questions based on graphs. Okay, so thank you very much. Thank you for watching this, and my code is Jeet1, so use it if you want to subscribe Unacademy Plus, like my videos.